So hello everyone, my name is Egidijus Lileika. I am security researcher at Digital AI, formerly at Arxon. I also used to be a security software engineer developing Android application protection product. So today I'm going to talk about virtualization on Android devices. Virtualization software is really nice utility, but we often overlook dangers associated with it. So today we're going to dig deeper into potential of Android software virtualization and how it can be utilized for malicious intents on non-rooted devices. So what is Android virtualization? When I'm talking about Android virtualization, I'm talking about the ability to run, to have multiple instances of the same app running on the same device. Or when you have ability to switch between multiple accounts seamlessly without need to log off and log in into another account. Or when you have a virtual device, like whole virtual device, running on your Android phone. So virtualization was, I think, was a good term to describe this kind of behavior. So how many of you are actually use virtualization apps, like parallel space or dual apps or anything else? Okay. Yeah, I personally used for Clash of Clans to play without. Yeah, it's really convenient. So let's go through Android virtualization types. So the first one is work profile isolation. So work profile isolation uses built-in Android feature called work profiles. Work profiles allow you to isolate apps and data on a separate space on your device. Island is a really good choice for that kind of virtualization that allows you to streamline the virtualization process on your phone. Another one is app cloning and repackaging. So virtualizers like that usually just repackages your application under unique package name, adds additional code, maybe hooks something else. And app cloner is a really popular choice for that kind of virtualization. Another type is application hosts. So virtualizers like that usually loads target virtualized application inside and acts as a proxy for communication with Android system. And Virtual APK is really popular open source project for that kind of virtualization. Next is whole Android system virtualization. So usually virtualizers like that actually even boot into ROMs. So it's something similar to emulators, but obviously native. Of course, this is the slowest type of virtualization because you have additional layers to go through. And, but on the other hand, it's the most powerful type. So TWOYI, interesting name, is really popular choice for that kind of virtualization. Last but not least is partial Android runtime virtualization. So virtualizers like that usually recreate majority of Android system with proxy and dummy processes. Usually we utilize the hooking heavily to intercept inter-process communication data and patch data dynamically. Of course, virtualizers like that suffer from stability issues because we always have to keep up with the newest Android versions and be compatible with the older ones. Virtual app is really popular choice for that kind of virtualization. So let's talk about intended use of virtualization apps. As I mentioned before, probably virtualization apps are used to have to log on into multiple accounts on one device and switch seamlessly between them without need to log out. Also, to separate your personal and professional accounts so we don't interact with each other and don't see each other in any way. And obviously, some people might use it to protect its own privacy. A lot of Google Play virtualizers claiming to be protecting your privacy, but I think this should be taken with a grain of salt, and I'll talk about this later. On the other end of user spectrum, we have threat actors, and virtualization apps can be used for malicious intents. So the biggest benefit of virtualization software, in my opinion, is because we can create a permissive environment in its own sandbox. basically it has full control over virtualized application. This kind of bypasses Android security model because virtualizer can decide whether this application it virtualizes is more privileged than another virtualized application. So this also called fake root. Also, a lot of open source virtualizers provide access to hooking services. So let's go through malicious activities you can do with virtualization software. So the first one is kind of obvious, hooking and dynamic instrumentation. As I mentioned before, virtualization software has full control over its own sandbox, over a virtualized application. It can easily inject any kind of code, including frameworks like Exposed or, for instance, Frida gadget. Those frameworks could be utilized to change application behavior dynamically without tampering your code integrity in any way. And often this is the baseline for other malicious activities. So another one is fake root. So fake root is basically a fake super user for virtualized applications. It can be utilized to run software like Game Guardian. So Game Guardian is like a cheat engine alternative for Android devices. In this clip, I'm launching TWI full Android virtualizer. It has a super user application which can grant access to super user for imported applications. And this is happening on non-rooted device. Another malicious activity is GPS spoofing. So GPS spoofing allows you to change coordinates to any location, thus bypasses geolocation-based verification or allows you to cheat in geolocation-based games. Next is dynamic analysis and sniffing. So in this demo, I'm launching a simple Simon application. It's an example app where you need to enter simple password credential to just get to another screen. And I was running this normally on device. Now I'm launching this on a modified virtualizer, which dynamically adds additional on text change listeners to every text edit box in application, and it logs all the changes to the logcat. This is really a naive example. This could be done more stealthily. A threat actor could just exfiltrate your personal identifiable information to his control server. All of this was achieved with just pure reflection, so no hooking. Hooking framework is not actually mandatory. Another activity is cheating in games. In this demo, I'm launching Memory Game. It's a really simple game where you need to flip cards, matching cards, as fast as possible. Take a look at the clock. It's counting down, so the faster you do it, the better score you get. Very simple game. Next, I'm launching this application in a virtualizer, modified virtualizer, obviously, which actually applies few things to the application dynamically. So the first thing you can notice at toast, that memory game mods were applied. The second thing, all levels are already 3 stars, so I just did a save hack. And another thing is, take a look at the clock, it's never counting down. So you have infinite amount of time to solve the puzzles. Yeah, so this is yet again, pretty primitive example, but I wanted to demonstrate that using virtualization software, you can modify application behavior dynamically without tampering APK or AB integrity or code in any way. Everything was done also with just reflection, but hooking frameworks could be utilized for easier modification. Last but not least is modding. So In this demo, I'm also launching memory game. And you'll notice a few things. The first one is add. So this add was injected dynamically. And another thing is modified game background. Also, I'm launching a simple Simon application just to demo that add injection can be done generically for any kind of application that uses Android views. In this case, I'm just getting access to the context. I can easily traverse through the window, through all views, and just insert my own dynamically generated view wherever I want. So ads are being injected whenever a new activity starts. So based on everything what I've shown, can virtualization apps actually be trusted? So virtualization apps can access your personally identifiable information and easily exfiltrate it without you even noticing. Also, it can inject any kind of code, including Android views, and inject adware or something else. Also, virtualization apps can modify application behavior without tampering application integrity in any way. So I'm a developer, what should I do? And my answer would be harden your application. So the first thing is to obfuscate your code. Obfuscation allows you to prevents static analysis of your application. Threat actor still needs to reverse engineer your application to do anything malicious with your application in order to find what to hook, where to inject or change the behavior of application. So obfuscation wins you a lot of time between releases of your app. The next thing is to perform environment checks. Virtualization software actually leaves a lot of artifacts in the environment that can indicate that you're running in virtualization software. Some of the virtualizers are actually really easy to detect. And last but not least is to detect hooking or hook framework presence that can help you a lot. So I'm a parallel space user, like regular user. What should I do? So my suggestion is to use built-in dual apps feature. Many vendors like Xiaomi, Samsung already have this built-in virtualizer in their operating system. So another thing is dual apps feature was already seen in Android 14 preview, so hopefully it will be released in future releases. Another suggestion is to use open source alternatives, especially work profile based ones. Shelter is really a nice choice for that kind of virtualization. And of course, don't use any important accounts. I wouldn't suggest to use banking accounts in virtualizer, or I don't know, like anything that maybe Google related with. Google is like central account that controls all of your accounts. So let's summarize everything I talked about today. Virtualization is useful for dynamic analysis in threat research. So I started utilizing virtualization software where hooking is not really allowed in day-to-day work. Virtualization can be used for malicious activity by threat actors, and they can do this stealthily without even you noticing, or to analyze your application, reverse engineer it, and so on. Privacy claims should be taken with a grain of salt, and that's because virtualization software has full control over a virtualized application, and I wouldn't entrust my privacy to that kind of software. Application hardening minimizes the risk for developers. It wins a lot of time between releases. Probably application hardening even will throw off attacker from even starting analyzing your application. Use of work profile-based open source alternatives is suggested for regular users. So that's it from me. If you want to talk more about this topic, we're at booth 29, so come and chat. Also, you can find my contacts in case you have a question. Also, I have a Medium blog post talking on the same topic. Maybe you will find more details on everything I talked about today. Also, I'm planning to write more blog posts in the same topic. So I really want to thank you for your attention.